so warm-up number 25. Once again, we've been working on these already for about a week or so, right? A week. Simplified to lowest terms, 1A and 1B. A is 24 over 60, and part B is 5t cubed over 10t squared plus 15t. Numbers 2 and 3 is factor. We got x squared for number 2, x squared plus 7x minus 18. And number 3, x cubed plus 8x squared plus 3x plus 24. Number 4 says solve for y, evaluate when the domain is -1, 0, and 1. And the equation given is -12x minus 3y equals -9. And number 5, it says add or subtract 12 15s plus 5 6s. All right, so with that said, being that it's Wednesday, by now you should have most of these down, out, cold, yes? Yes, Mr. Q. All right, good. So let's start with 1A. What'd you get for 1A, Lenny? 2 over 5. Hands, have you got that? That is correct. Now, I asked you guys to start off with a GCF. The GCF for these two is 12 and 12, yes? 12 times 2, 12 times 5. And if we identify a giant 1, here's a giant 1, 12 over 12, and we're left with what? 2/5. All right. Number 1B. What'd you get for 1B? Andrew. T squared over 2t plus 3. Hands, have you got that? That is correct. How did you get there? This is 5 times t times t times t. And this one, GCF, is 5t, and we're left with 2t plus 3. The giant 1 is the 5 and 1t, and we're left with these 2t's and 2t plus 3. Now, why can't we get another giant 1 here inside? Because there's addition right there, and we cannot do that when there's addition or subtraction. Okay. Number 2. For number 2, let me go over number 2 really quick. Check this out. Standard form, yes. GCF, no. So therefore, to factor that is leading coefficient is 1 times -18 is -18. Middle term is 7. What factors of -18 add up to 7, positive 7? -2 times 9. -2 times 9 is -18. -2 plus 9 is 7. Now check this out. Look up to the screen. Very important. From this point forward, I'm going to allow you to use a shortcut. Ready? Ready for the shortcut? Here it goes. Whenever you have a trinomial like this, and you get to this point, if it doesn't have any number there, because we're assuming it's 1, yes? We can go straight to getting our factors from here. What is this number? 2, so it's x minus 2, and this one, x plus 9. You're like, what? What? Yes. Now, why did we do all the other stuff? Because I wanted you to work on what? Factor by grouping. Now that we have that down, now we can do the shortcut for this. Why? Because for these, we still need to do grouping, don't we? Yes, group. GCF here is x squared. We're left with x plus 8. Plus GCF here is 3. We're left with x plus 8. So my factors are x plus 8. And what's left? X squared plus 3. And these are my factors. Hands, have you got that for number 3? Okay? So once again, make a note for yourself, because today we're going to have to factor a little bit faster. So I'm going to allow you to use this shortcut. Once you get the 2 numbers here, you can get your factors straight from there without doing all the extra work. Okay? We got it? Yes, Mr. Q, thank you. You're welcome. Number 4. Let's see, what'd you get for number 4? We need to solve for y. What'd you get for y? Pamela? -4x plus 3. Hands, have you got that? Okay, good. I got the domain, x. All x values of the domain, -1, 0, and 1. What you get for the range, Andy? Range. 7. 3, -1. Hands, have you got that? That is correct. Let's go. And last but not least, number 5. What you get for number 5? Carlos. 29/30. Hands, have you got that? That is correct. Let me go over the process one more time because we're getting there pretty soon. So the process was, numerator stays the same on both. I identify the GCF for these two. The GCF was what? 3 times 5 and 3 times 2, yes? Alright, so what does this one need? A 5. What does this one need? A 2. So, 2 times 2 is 4. 2 times 5 is 10 times 3, that's 30. 5 times 5 is 25. 2 times 5 is 10 times 3, that's 30. 1 fraction, that's 29. And there you go. Tell me the same stuff. Let's see. Who got all 5 of them by now? Yeah, some of you. How about 4 of them? Okay, so the rest of you. So hopefully about tomorrow, we should get all 5 of them, yes? Yes, Mr. Q. All right, copy the agenda for today. Agenda, warm-up number 25. Today we're moving on to simplifying rational expressions. Yeah, let's go. That sounds good, right? Sounds like very welcoming instead of saying simplifying fractions with a bunch of polynomials, right? Doesn't it sound better like that? Home play sheet practice A, 10.3, all only. Copy that really quick. All right. So, your Nearpod code, copy this down, K72HZ. K72HZ. So those of you that are watching online, make sure you type in that code in there. You're going to have the home play in PDF format. And everybody here, as well as those of you watching online, go from there all the way to the end of the presentation and take the poll. Yes, at the end, take the poll. I want to see where you're at with rationals after today. Okay? Yes, Mr. Q. All right. So last night, I left you guys some home play. 6 itty-bitty problems, which turned out to be 10, yes? Because some of them you need to do 3 different ways. 2 of them, right? The first 2. All right. So take a picture of that, submit on Canvas. I want you to write your name, date, period on it, and send that forward, please. And once again, tonight's home play is going to be play sheet practice A 10.3. It's on Canvas and it's on Nearpod. And I'll give you some time for that so we can get started. There's our objective. Get your Cornell note ready. You do need a fair model today. All right, here we go. Our objective for today, I can simplify rational expressions. I can simplify rational expressions. What is our new concept for today? Rational expressions. Okay, so what are they? Here we go. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Bless you. Now, by now, all those words in the definition should be familiar with us. Why? Because we've been using them. At the beginning of the school year, I started with algebraic expressions. We said they were expressions that had a variable. Okay, can you picture that? Yes. But then it says whose numerator and denominator are polynomials. So, if they're saying numerator and denominator, what are they implying? That the expression is a what? A fraction. Okay. And it's a fraction now that has what? Polynomials. Let's go. Examples. Copy these. 6 over g plus 4. 2x plus 1 over x squared minus 15x. 2x plus 6 over x squared plus 5x plus 6. All those are examples of rational expressions. So once again, rational expressions are algebraic expressions. Are they all expressions? Let's see. Expression, expression, expression. Yes. Now, just by looking at them, it's obvious that they are expressions. Why? Tell your neighbor why it's obvious that they are expressions. Tell your neighbor, what makes them expressions? Yeah, I heard because they don't have a what? Equal sign. Yes, that's why they're expressions. Okay. Now, numerator and denominator. Do they have a numerator and denominator? Yes. Also, do they have polynomials? Yes, polynomials all over the place. So, students, rational expressions, students. All right. What are they not? Look at these. Don't copy them yet. Tell your neighbor why these are not rational expressions. Obviously, because they are what? Equations. Yes, copy that, please. All right. So, you would be hashtagging this and sending it to your BFF. So, Juliana, hashtag what makes a rational expression a rational expression? Polynomials, yes. Now, let's say your little cousin or your little person in your life that comes and wants to take their snacks away or wants to play the games you play at the same time and wants to change the channel and all that. They come in and you want to tell them what these are. What would be a simple word for that? Hashtag what? Fractions. Yes, that is correct. Fractions. Okay? And also, obvious, all of these are what? Hashtag what? Expressions, yes. Alright, now that we know what they are, what we're working with, today I'm going to do a quick intro using a definition. For those of you that were with me in 8th grade, you're going to see, and it's going to be familiar. Look up to the screen, don't copy this. So I'm going to introduce the definition of fractions, also known as rational numbers or rational expressions. Ready? Here it goes. Don't copy this. There's a definition. But now we can actually follow the definition because, here it goes. I'm going to start here. The set of all fractions, can you follow so far? Where we have m in the numerator and on the denominator, such that m and n are what? Integers. Can you picture all those numbers? Yes? Okay. However, n cannot be 0. That means the denominator cannot be 0. Okay. Now, taking you back to when you started graphing at the middle school level, they gave you a line that was straight up and down, a vertical. The slope was undefined because we couldn't tell whether it was going up or down. That was undefined. That's why the numerator cannot be 0. Okay. Now, why use the letter Q? Because what does a fraction imply? What operation? Division. What is the result of a division? A quotient. Did we work on that? Yes, that's why we use the letter Q. Not because of Mr. Q, but I know, right? That would be cool. So, today we're going to be doing two things. The first one, we need to find out, I'm going to give you fractions with polynomials. We need to find out a value that we cannot use on the denominator because it's going to make it 0. That's what we call the excluded value. We're going to be finding the excluded value. The second thing we're going to do, we're going to simplify the rational expression. So, let's get started, yeah? Copy these steps, please, under your prayer model. 3 simple steps for today. Step number 1 is identifying the excluded value. And it says, identify the excluded value. And in parentheses, I write the process. It says, write the denominator equal to 0 and solve. Steps 2 and 3 is to simplify the rational expression. Step 2 reads factor completely the numerator and denominator, which you can also use the DCF. And number 3, simplify after identifying giant 1. And you're going to see how step 2 and 3 we've been doing on the warm-up already, so it's going to be a lot easier to transfer to what we do today. Copy that, please. All right. So, y'all ready? Okay, if you haven't finished writing the process, I'm going to leave them on the top right of the screen so you can finish copying, but let's get started by copying example number 1. I'm going to start slow. Here we go. Example number 1 reads, identify the excluded value, then simplify to lowest terms. The rational expression given is 2x over 2x plus 6. Just copy that. I'll go through the process, and then we'll do one together, okay? All right, so look at the instructions. What are the two things we're doing? First, we're identifying the excluded value. And what are we doing after that? Simplifying. Okay, so here we go. Writing utensils down, look up to the screen. So what I'm going to do first, finding the excluded value, has nothing to do with simplification. Am I being clear of that? Yes? Okay. So what I'm going to do, I'm going to do the excluded value over here, so like that you don't get confused that it's also part of simplification. So I'm going to write over here EV. What does EV stand for? Excluded value. Okay. What does the instruction say, the ones I gave you? It says write the denominator equal to 0 and solve. So what's my denominator? 2x plus 6 equal to 0. Can I solve that? Yes. What do? Minus 6 minus 6, 2x equals to negative 6, divide by 2, x equals negative 3. All right, what is that number that we just found? Well, we found that number, and what that means that if I substitute that in here, it makes the denominator 0. So what does that mean, Mr. Q? That later on when we solve equations involving fractions like these, we cannot use what number? Negative 3, because it makes the denominator 0. Now let me check just to make sure that it is an excluded value. What do? I write this again, 2 parentheses plus 6, but instead of x, what am I going to write? Negative 3. What is 2 times negative 3? Negative 6. What is negative 6 plus 6? 0. Yeah, so this is my excluded value. Copy that, please. Fairly simple, yes? From 1 to 5, how come we are finding the excluded value? 5, 5, 4, 5, 4, yes. This should be straightforward because the instructions are there and we can go from there. All right, let's move on to the second thing that I'm going to be asking you to do on the home plate. What is the second thing? To simplify to lowest terms. All right, we've been doing that on the warm-up, so hopefully it should be easy to do today. So I'm going to follow these two steps. What is the first thing they ask us to do? Factor completely. Can I factor the numerator anymore? No, so I just leave it as 2 times x, okay? How about the denominator? Can I factor that? Yes, what's the GCF? 2, and that leaves us with x plus 3. All right, from there, can I identify giant ones? Yes, 2 over 2 is 1. Can I also do x over x? So you never, why not? Yeah, because of the addition sign. We can't do that when there's addition or subtraction, so therefore we're left with x over x plus 3. Copy that, please. You're like, what? We've been doing this. Yes, we've been doing this. All right. From 1 to 5, how comfortable are you with simplification? Yeah, 5, 5, 5, 5, okay. How about with excluded values? Yes. We got this, yes? Okay. So once again, on the home plate, some problems are going to say simplify. So does that mean that you're also going to do excluded values? No. And some problems are only going to ask you to find the excluded values. Are you going to simplify? No. They're just do whatever they're asking you to do. All right, let's do another one. Copy this. Example 1Q. 6x over 3x plus 9. All right, let's do this one together. Here we go. First, let's start with our excluded value. I'm going to do that over here. Excluded value. All right, what do I write, Lenny? 3x plus 9 equals 0. Continue, Andy. What do I do? negative 9, negative 9. 3x equals negative 9, and then divide by 3. Therefore, x equals negative 3. So according to Andy, x equals negative 3. That's our excluded value. How can we check? Well, we substitute it in there. So it's 3 parentheses plus 9. Instead of x, I'm going to substitute negative 3. What is 3 times negative 3? Negative 9 plus 9, that is 0. So that means this is our excluded value. And if you got that. Okay? Let's go to simplification, which is totally different from excluded values. Okay? Let's look at the numerator. How can I factor completely the numerator? Look at it. Tell your neighbor, what would be a complete factored form of 6x? Tell your neighbor, please. All right, Audrina, what is completely factored 6x? 2 times 3 times x. That is correct. Copy that. All right. Let's go to the denominator. Look at the denominator. What would be the factors for the denominator? Raymond. 3 and x plus 3. That is correct. And have you got that? Yes. Can we identify now the giant ones? Alexa, what are my giant one? 3 over 3. That is correct. Can I do x over x? No, because of what? The addition. So what does that leave us with? 2x over x plus 3. From 1 to 5, how come to be a few of these? Yeah, we got this, yes? 5 fourths, 5 fourths? Crank it up a notch, yes? Brooke says, yes. Mr. Q, bring it. All right, here you go. X squared over x squared minus 5x. You're like, oh, snap. I know, right? All right, let's do this one together. Then I'll give you one just like it to do by yourself. Here we go. Excluded value. Excluded value, what do I write, Bree? X squared minus 5x equals to 0. That is correct. Okay. So now, look at it. It looks kind of weird, doesn't it? But what do you notice? It's a difference. This one has a square. Let's see if it's a difference of squares. Can I take the square root of this one? Yes. How about the square root of that one? No, it doesn't work. So we can't do that. Can we factor? Yeah, what's our GCF? X, so we're left with x minus 5. Now that equals to 0. So now that we have two factors equal to 0, that means x equals to 0, x minus 5 equals to 0, and we solve. This one's already solved, and this one we just add 5 at 5, x equals 5. I'm not going to check. We can do that mentally. Watch. If I substitute 0 in here, what is 0 squared? 0. What is negative 5 times 0? 0. So that is a 0. How about this one? What is 5 squared? 25. What is negative 5 times 5? Negative 25. Then that becomes 0. Okay. So we're done with excluded value. Let's go to simplify. Before I move on, though, look up. We got how many excluded values now? 2. Look at the denominator. Just by looking at it, it should be obvious why now we have 2 excluded values. Tell your neighbor how we can tell. All right, help us out, Rachel. How can we tell that there's 2 excluded values? Because it's squared. That is correct. This one has a 2. Let's go to the previous one. The previous one, what is the exponent on the variable? 1. That's why we only get 1 excluded value. So what does that tell you? That if you had an x cubed, how many excluded values? 3, and so on and so forth. Okay. Let's go to simplify. Here we go. How can we write this as factored form? X times x. Very good. How can we factor this one? You're like, Mr. Q, we already did it over here. Oh yeah, that's true. It's right there, so I just use these factors and write them here, x minus 5. And now we can identify the giant 1. You guys see the giant 1? Yeah, x over x, and that leaves us with x over x minus 5. And tell your neighbor why we don't do a giant 1 there. Yeah, there's a subtraction right there. That's why we can't. All right, show me your fingers. How confused you are with these? 5, 5, 5, 5, 5, 5, 4. Okay. Do another one. You're going to do this next one by yourself. Very similar to this one. Here we go. Example 1 mega q, 2x over x squared plus 7x. Find me the excluded value, and then from there go to simplify to lowest terms. Copy that and go. Alright. So, excluded values. What'd you get for that, Brianna? X equals 0 and x equals what? Negative 7. Hands, have you got that? That is correct. How did you get that? X squared plus 7x equals 0. GCF is x plus 7 equals 0. Then x equal to 0, x plus 7 equal to 0. Solve for x here, and that's how we get there. Okay, so far so good. Let's simplify. Christian, can we factor the numerator anymore? No, so it's 2 times x, okay. How about the denominator? Yes, which is already here. We already did it, so we end up with what? X times x plus 7. Okay. Giant 1, yes? X over x. That leaves us with 2 over x plus 7. Hands, have you got that? Alright? We good? Alright. Let's crank it up a notch, yeah? Oh yeah, let's go. Yeah, copy this one. Example 1 super duper cube. 6x squared minus 6x over 3x minus 3. The excluded value should be a piece of cake. And then I'll wait for you so we can do the simplification together. The excluded value. Help me with this one, Jessica. What do I write for the excluded value? Get me started. X minus 3 equals to 0, yes, and then we just solve, yes? Dana, go. Add 3 to each side, yes. 3x equals 3, and at the end we divide by 3. So my excluded value is what? 1. Okay. I'm not going to check it since we all did this one together. Okay, let's go to factor. Alright, look at the numerator. Can we factor that? Yes, by looking for what? GCF. What's our GCF? 6x, okay, and that leaves us with 1x minus 6x divided by 6x is 1. Okay. How about the denominator, Juliana? What's our GCF? 3. And we're left with x minus 1. Okay, so far so good. However, look at the numerator. Can we factor the numerator a little bit more here? What is 6? 2 times 3. Okay, so I'm going to erase the 6 for right now, leave it at 2 times 3. So that it's obvious that we can see the giant 1, yes? Alright, tell your neighbor the giant 1s, not just giant 1, giant 1s. Yeah, some of you already saw it. You saw the first one, obviously, 3 over 3, right? However, the second one, who saw that this is exactly the same as this? That's a giant 1. Did I make a point there? Yeah? So what does that leave us with? 2 and x, so this is 2x. Woo, let's go. Man. Too easy. My goodness. Right? They should put these behind the cornflakes boxes or something, right?
Yeah.
Like tic-tac-toe, yeah? Crank it up a notch, yes? Before I move on, 1 to 5, how comfortable are you so far up to right now? 4, 5, 5, 5, 5, 4, okay? Let's do another one. Here we go. Copy, let me see. Give me a second. Now let's crank it up a notch. Copy this one. Example 1, Star Wars Q, x squared minus 4 over x squared plus 3x plus 2. Alright, so let's start with the excluded value. And let's see, Thomas is going to guide us with that one. So excluded value. Go, Thomas. What do I write? Equals 0. Yes, thank you. Pass it to someone. Who? Brianna? Brianna or Bree right there? Bree. All right. Bree, can we factor that in order to start solving? Yeah, so what do I do? Power Rangers. So what goes on top? 2. What goes on the bottom? 3. So what factors of 2 add up to 3? Everyone? 1 and 2. Now question. Does this one have a number that's a leading coefficient? No. So can we write our factors straight from there? Yeah, which are what? X plus 1, x plus 2. You're like, what? What? All right, Ricardo, go. What do I do? That is correct. X plus 1 equals 0, x plus 2 equals 0, and let's solve. Minus 1 minus 1, x equals negative 1, minus 2 minus 2, x equals negative 2. Alright, so these are my what? Excluded values. Okay, from 1 to 5, how comfortable are you with that so far? 4, 5, 5, 4, 5, yeah. Yeah, it's stuff that we've been practicing, yes? Good thing you do your home play. My goodness. Alright, let's go to simplifying this. Alright, let's see how much we practice. You should be able to take the numerator and factor that automatically by now. Tell your neighbor the factors of x squared minus 4. And hint, here goes the hint. It's a difference of squares. Yes, okay. So I think Sky's got it. What are my factors, Sky? Close. X plus 2 and x minus 2. That is correct. How do we get there? For those of you that forgot, those of you watching online, you take the square root of this one, that gives us x. Take the square root of this one, that gives us 2. Since it's a difference, you write it twice, one positive, one negative. Okay? All right. Can we factor this one? Yes, Mr. Q, we already did earlier. What are my factors? They're right there, which is what? X plus 1 and x plus 2. Do you see the giant 1 now? Yes. What are they? X plus 2. Can we do that? Yes. Why? Because there's multiplication there and multiplication there. That is correct. So what do we have at the end? X minus 2 over X plus 1. How are we doing? Yes? From 1 to 5 with these now. How are we doing? 5. Andy's all showing me 2 and then he's off. And 3. Okay. Yeah. That's good. That's good. Yeah. All of a sudden he was scaring me. I was like, what? All right, let's move on to another one. Yeah. Here we go. Example 1, Michael Jordan Q. So we got x squared minus 3x minus 4 on the numerator over x squared minus 4 on the denominator. Let's work on the excluded value first. Let's see. Tell me what to write, Brooke. Excluded value. X to the power of 2 minus 4 equal to 0. Okay. Now, to solve this, we can use different methods. We can try first with factoring, or we can also try with what? Who remembers the other method? Square root. Ricardo says, can we try square root for this one, see if it works? All right, what would we do? Plus 4 plus 4. We're left with x squared equals 4. And then our square root method, square root, square root. So what is my solution? Plus minus 4. So what are my excluded values? Positive 4 or negative 4? Oh, 2. Yeah, I did that to see if you were paying attention. Be nice. All right, yes, 2. Positive 2, negative 2. Okay? All right. Let's go over here. So we're done with the excluded value. Let's go to factoring. Okay. Can we factor this one? Yeah, what do I use? Negative 4 goes on top. Negative 3 on the bottom. What factors of negative 4 add to give us negative 3? Tell your neighbor, what factors of negative 4, if you add them, give us negative 3? All right. Sandra, what factors of negative 4 add up to negative 3? 1 and negative 4. Let's see, 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. So if I wanted to write the factors from there, what would be my factors, guys? X plus 1 and x minus 4, yes. Now look at this one. This is difference of squares. Tell your neighbor the factors of that one. What are they? X plus 2 and x minus 2. Okay. Are there any giant ones? No. So then we're done up to right there. From 1 to 5, how completely you feel with these? Yes. 5, 5 4s. 3, we just need to practice. Alright, so we'll stop right there. Your home plate, once again, guys, it's going to be the play sheet that's on Canvas. Or it's also on Nearpod. Make sure you go into Nearpod and get your play sheet there and do the whatchamacallit, the poll. Have a good one, guys. See you guys tomorrow. Bye.